Hello, this is Mr. McMurray, and we are here at Paradise High School on a bright and sunny, Monday morning. All right, so what are we going to do today? Well, we're going to talk about chemical reactions. All right, this is the chemical reaction worksheet. Now, there are four main types. We looked it up here. In this particular one, if we have a reactant and we add it to another reactant, and we end up with one product. All right. So in other words, we're putting two chemicals together to make a final product over here. All right. Put that where it belongs. So anytime you have a synthesis reaction, you have two or more reactants that you put together and you end up with only one product. So you can always tell a synthesis reaction because on the right side, what we end up with, you're always going to have one thing, and on the left side, the reactants, you're going to have more than one thing. Okay? Now, decomposition is kind of the opposite of that. All right? In decomposition, you have one reactant, and then after the reaction, it breaks down. It's kind of what decomposing means. I mean, decomposing is breaking down. All right. And so you have two products. So if you have one reactant, start off with one chemical and end up with two or more, that is decomposition. Now, so synthesis and decomposition both have either one product or one reactant. Right? The other two type of reactions we're going to talk about here have two on both sides. All right. So here we have a reactant and we have a reactant. And over here we have two products as well. All right. A and XB over here. Okay, these are both products. Now, down here in this next kind, we also have, once again, no, that didn't help much, because we have two reactants. And we also have two products. So by this one, we can't just tell by the number of reactants and the number of products how many we have. So here we go. So we have two reactants per product. How do we tell the difference? Well, in single replacement, you have a single element by itself that takes the place or boots out an element that's part of a compound. And so then the element that was part of the compound, A in this case, ends up all by itself, and X takes its place in the compound. All right. We said this is kind of like if you and your date went out and your friend went with you and your friend took your place and booted you out. Sad, but it could happen. All right. Double replacement is where you have two couples, so like a double date, but they decide they like each other's date better and they swap dates, hopefully peacefully and friendly, but probably not. Anyhow, and so they switch partners. That would be a double replacement because two elements are swapping places in two different compounds. All right. So basically, if it has one product or one reactant, it's going to have to either be synthesis or decomposition. If it's one product, synthesis. If it's one reactant, decomposition. If it has two on each side, it's either going to be single or double replacement. If it's an element plus a compound, it's going to be single replacement. If it's a compound plus a compound and you end up with two compounds, but they just trade partners, that's going to be a double replacement. So let's look at some examples down here and do those. All right. So the first thing I would do is put your reactants and your products. Anything on the left side of the arrow is going to be a reactant. If there's a plus sign between them, then there are two separate ones. If there is no plus sign, okay, so for example, if we look over here on the right side of the arrow, that's going to be the products, and there's no plus between the NaCl, so that means they have joined together. All right. So first of all, we can do is just the type of reaction. Well, we have one product. Well, the only way you can have one product is if they're combining. So we can say right off the bat that the reaction type is synthesis. All right. All right. Now, the next part is naming them, but we'll come back to that in a minute. All right. All right. If we go to this one, we have a reactant. Oops. We know that's a reactant, and we know this is a reactant. So we have two reactants. And we have on the other side, we have two products. I may quit typing these down. I'm going to just let you write them down. But anyhow, two products. Okay, so we know if there's two reactants, two products, it's going to have to either be single or double replacement here. And the question is it an element plus a compound, or is it a compound plus a compound? Well, this one has three elements in it. This one has two. So these are obviously compounds. So what happens is the Ag and the K are just swapping places. So this would have to be a double. Oops, whoa, there we go. Hang on, I just lost it there. Double replacement reaction. So that's going to be a double replacement reaction. All right, now let's go back and do some naming. All right, first of all, let's write some rules up here. If you have two elements, the second element is going to end in IDE. All right. If you have three elements and the last one is an oxygen, then the second element is going to end in ATE. All right. And the last one, anytime you have an OH group together like that and written like that, that is called hydroxide. Okay. So let's go look down here and name of our elements. Okay. First of all here, we have Na, which we know is sodium. Maybe look up in your periodic table if you need to. And Cl, which we also know is chlorine, hopefully. That's just the name of the element. All right, we'll put our arrow. All right, they change into sodium and chlorine joined together. Now, there are two elements, so you always write the name of the first element. In this case, the first element is sodium, so it's going to be sodium. And you put IDE on the second one, so it's going to be chloride instead of chlorine. Okay, and that would be it for that one. You're done. Now for this one down here, it's going to be a little more complicated. You may have to write a little smaller to make it fit. It is going to be Ag, which is, that's right, silver. And it has nitrogen and oxygen. So there's three elements in this compound. It does have oxygen on the end, so we're going to put ATE, but not on the oxygen, but on the second one, because we're always going to have two. The way we're naming these, we will always have no more than two words in the name. So nitrogen with AT on the end could be nitrogenate, but it's actually going to be shorter than that. It's going to be nitrate. Whoops. And I kind of messed that up. Okay. All right, silver nitrate. All right, plus K, which is potassium. All right. And it's just oxygen joined to it. And since there's two elements, we put IDE on oxygen, so it's going to be oxide. All right. Then we have the arrow. All right. Now, not only do the elements trade places, but basically the name trade places. So instead of silver nitrate, now we have K there, so it is going to be potassium nitrate plus silver oxide. Okay. Now, sometimes you may see these in parentheses, the numbers change, but basically the silver nitrate plus potassium oxide, the names are just going to trade places as well. It's going to be potassium nitrate instead of silver nitrate, and silver oxide instead of potassium oxide. So they just kind of swap their names. Okay. All right. Then the last thing is OH down here. Don't forget when you name this, like this one would be, right, the name of the first one was hydrogen. OH would be hydroxide, so this would be hydrogen hydroxide. And just for the record, that's also known as water because you have two H's and one O. All right. Yeah, so that's what I'd like for you to do the rest. Always do the R's and the P's first, then do the type of reaction, and then come back and write the names of the compounds. All right. All right, that's all I have for you then. Have a great day and enjoy the worksheet.